Lesson 18.2, Task 1, Dependent and Independent Events. Determine the independence of events. Recall that a conditional probability calculates the probability that some event A occurs given that some event B has already occurred. Sometimes one event occurring or not occurring affects the outcome of the other event. For example, consider the probabilities of drawing even or odd number tiles when choosing two of the number tiles shown below, one at a time, from a bag. If you replace the first tile before you draw the second one, you have restored the original sample space ahead of drawing the second tile. That makes the two tiles independent events. The occurrence or non-occurrence of one event will not affect the probability of the other event. Now consider drawing the second tile without first replacing the first tile. The first draw having occurred now affects the probability of the second event because the sample space has changed. This makes the two tiles dependent events. The occurrence or non-occurrence of one event does affect the probability of the other event. All right, so dependent and independent events, those are two of your vocabulary terms that you need to know. So make sure you have those. And we're going to look at number 1 here. It says a survey was given to 100 students. 2 of the survey questions asked students if they drink milk and if they like yogurt. The results of the survey for the 2 questions are shown in the two-way frequency table. All right, so you can see here, drinks milk. There are 80 students who drink milk and does not drink milk. There are 20 students who do not drink milk for a total of 100 students. Likes yogurt. There are 55 students who like yogurt and there are 45 students who dislike yogurt, and again that equals 100. All right, so we're going to use the table to answer some questions. So it says the probability that a student who likes yogurt also drinks milk is the conditional probability P of A, B, where event A is drinks milk and event B is likes yogurt. First, find that the total number of students who like yogurt is 55. So you can see right here, this is 55. Of the students who like yogurt, 44 drink milk. Write the probability that a student who likes yogurt also drinks milk. So the probability of AB is 44 over 55. So 44 over 55. And that, if you calculate that, is 80%. And then the probability that a student drinks milk, drinks milk is 80. 80 out of the 100. Is also 80%. So those two things were equal. So what do you notice about the probability of P of AB, the conditional probability of AB, and P of A? So those two are equal. All right, for the same event, A and B, find the probabilities of P of BA and P of B, given your answer as a whole number. All right, so we're switching the order. We're doing the conditional probability of BA. So that means drinks milk and likes yogurt. So right here it was likes yogurt and drinks milk. That's AB. So to find the probability of BA, we have to switch the order here. So we need to find the probability that they drink milk. Okay, here's drinks milk and likes yogurt. So 44 out of 80. So if we do 44 out of 80, all right, so 0.55 is 55%. Remember to go from a decimal to a percent. You have to move it 2 decimal places. Now let's find the probability of B. So the probability of B, so the probability of A is drinks milk. The probability of B is likes yogurt. So likes yogurt would be 55 out of 100. So let's see what 55 divided by 100 is also 55%. All right, so what do you notice about these probabilities? These are also equal. All right, do you think one event affects the probability of the other event? Explain. Are the events that a student likes yogurt and that a student drinks milk independent? Yes, I do think these are independent events. What happens in one is not affecting the other. So let's see what it says. It says, no, the probability drinks milks is the same as drinks milk given a student likes yogurt. Then likes yogurt has no effect on whether or not the student drinks milk. If the probability likes yogurt is the same as likes yogurt given the student drinks milk, then drinks milk does not have any effect on whether or not the student likes yogurt. So yes, they are independent. All right, so you might not think that because you would think milk and yogurt, both dairy products, but in this case, using your table here, these are independent events. All right, that's all for task 1. If you have any questions, let me know. Lesson 18.2, task 2. Show events are independent. You observed in the previous task that when A and B are independent events, then the probability of AB equals the probability of A, and the probability of BA equals the probability of B. The following formula can be used to test whether two events are independent. All right, so if you have the probability of independent events for events A and B, events A and B are independent if and only if. This is very important, if and only if. That means if one thing happens, the other has to happen. If the probability of A intersect B equals the probability of A times the probability of B. So you can multiply these together. You studied the formula for conditional probability in the previous lesson, okay? Given that when A and B are independent events, the probability of A, B equals the probability of A. You can derive the formula for the probability of independent events from the formula of conditional probability. All right, so remember this is the symbol for conditional probability. So you can derive the formula for independent events from this. So for independent events A and B, okay, so we have our conditional probability here, and that equals the probability of A intersect B divided by the probability of B. This is your conditional probability formula. We looked at this in a previous lesson, okay? All right, so we're going to replace the probability of AB with the probability of A, because remember we looked up here and we said that we know that these two things are equal from the previous task. So we're going to replace the probability of conditional probability of AB with the probability of A because the events are independent, all right? So if we do that, now if we multiply both sides by the denominator here, which is the probability of B, that produces this right here. So that's how we get the probability of A times the probability of B equals the probability of A intersect B. All right, so how can you use the formula of probability of A times probability of B equals the probability of A intersect B to show that the conditional probability of BA equals the probability of B when A and B are independent events. So all we're going to do is fill in the steps and the rationale for each. So if you look down through here, we have some things that look like, these three things look like they are rationale, and then we have three things that look like a formula. So to begin with, we're going to start with what we know. This right here, maybe, if I can get it to drop in there. There we go. Because that right there is given. So this was given to us in the question. All right, so from there, we can let's look at what else we have. We have this here. So if we divide both sides by A, P of A right here, then we would have this right here. So I'm trying to look at how we can go from one step to the next step. All right, so this, if we divide both steps or both sides by P of B, P of A, then that gives us P of B equals this right here. All right, so what did we do? Excuse me. We divided both sides by P of A. All right, so there should only be a couple choices left. So we're going to have P of B equals conditional probability of BA, and that's going to be definition of conditional probability. So if you look at what you have, like the choices you have, and kind of logically make sense, then you can just fill in those blanks that way. All right. Describe how you can use the formula for the probability of independent events to determine whether two events are independent. All right, so we're going to blank the probabilities PA and P of B. So we're going to multiply those two events together and compare the product. The product is their answer after you multiply, right? So the product of the probability, if they are equal, then the events A and B are independent. All right, the next thing says if the probability of A times the probability of B is not equal to the probability of A intersect B, what do you know about the events A and B? Fill in the words dependent and or independent. All right, so the events are not independent, so they are dependent. And that's because it says right here that if you multiply, they're not equal. So that's how we know they're not independent. They would be dependent on each other if those two events are not equal. All right, so a survey of 187 college freshmen and sophomores were asked if they were taking any early morning classes. The results of the survey are shown in the two-way frequency table. Use the table for part D. All right, so you can see the number of freshmen here, 0.529, sophomores, 0.471, early classes, only 0.272, no early classes, the majority of the students, 0.728, but these will equal 1, each one of these will equal 1. So it looks like the majority of students do not take early morning classes, but out of the ones who do, well, it looks like it's pretty even for freshmen and sophomores. So let's see what the question says. Let event A represent a student taking early morning classes, and let event B represent a student being a freshman. So we've got early morning classes and freshmen. If events A and B are independent, what should be true about the relevant frequencies? Verify your predictions. All right, so that means the A and B multiplied together would be equal, then they would be independent events. So it says if they are independent, then P of A times P of B equals P of A intersect B, or the product of early classes and freshmen should equal early classes and freshmen. From the table, early classes equal 0.272, freshmen equals 0.529. Okay, right here and right here. So it says, and P of early classes and freshmen is 0.144. So because when you multiply these together, you get that confirms that the events are independent. All right, that's all for task 2. If you have any questions, let me know.